Here we go. We're on example 5 in section 1.2. Letter A. They want you to take negative parentheses 1/3 x, and we're going to square the whole thing. They want to know what transformations of x squared result in the graph of this function. Okay, so we're looking at multiple transformations, more than one thing happening to the graph. First of all, let's look on the outside here at this negative sign. I think we know from our previous lesson that if there's a negative outside the parent function, it's going to flip the graph vertically. So this parabola, y equals x squared, is going to flip over and be upside down. That's one thing that will happen. Next, we need to take a look at the 1/3 that is inside the parent function prior to being squared. First of all, anything happening on the inside is going to affect the horizontal coordinate, so the x's will be affected. This thing will either get wider or it's going to get narrower. Now, from our previous studies, we should know that a scale factor that's in there, 1/3, it's kind of backwards. It's the opposite of what you might think happens. So 1/3 is actually going to stretch the graph horizontally. And it's going to be by a factor of 3. It's the reciprocal of 1/3. So it's going to stretch it out by a factor of 3. So on the parent function, x squared, you would have points like 0, 0, 1, 1, 2, 4. My prediction is that on this new function called g of x, you're going to still have 0, 0. You're going to have 1, 1 is going to stretch, and that x coordinate is going to get multiplied by 3, but the y will stay the same. And for the third point, the point 2, 4, I predict that we're going to see a point at 6, 4. The x's are going to be multiplied by 3. Keeping in mind that it's going to flip upside down, so the y coordinates will be 0, -1, -4. So we're going to pop this into the graphing calculator and see if those 3 points show up on our red graph. 0, 0, 3, -1, and 6, -4. Off to the calculator we go. X squared is already loaded in for y1. Let's go ahead and I have the next example already loaded into y3. I'm going to turn that off. You could type that in later. Let's go to y2, and we want to put in negative parentheses. If you want to do 1/3 as a fraction, go to alpha y equals. You see here you can put something in fractional form with option 1. That was alpha y equals option 1. If those menus are not popping up for you, you need to see me in class, and we'll try to get you the operating system that allows you to create fractions. There we go. We're going to put 1/3 in there. 1, down, 3. Arrow to the right to get out of the fraction. Then we're going to type in our x. Then we're going to close our parentheses and square it. So what I should see is I should see the parent function y equals x squared in black, and I should see the transformed function upside down and wider in red graph. Parent, transformed. It's wider, it's upside down, and we can trace to the points that we thought we would see. Currently I'm tracing y1. Press down to trace y2. Just enter the numbers that you're trying to trace to. It's already on 0, 0. Let's check to see what happens when x is 3. I think y will be -1. When x is 6, I think y will be -4. So there we go. We have a horizontal stretch by a factor of 3, and we have a vertical flip. Example B. Let's move on. Here we go. We're looking at g of x this time. I don't think I'm actually going to bother graphing this one. This one's pretty straightforward. It's going to move 2 ways. The -4 on the inside is going to make it go right 4, and the plus 5 on the outside is going to make it go up 5. That concludes example 5. If you have any questions on those, let me know next time you see me in class.